So today's presentation is Pulsar Functions, a deep dive. Sanjeev, thank you so much for joining us today. Very excited. So Sanjeev comes from Splunk, where he works on their data streaming processing product. Prior to Splunk, he was the co-founder and CTO of Streamlio, which led the development of Apache Pulsar. Prior to Streamlio, he led the streaming compute team at Twitter, where he and his team were responsible for developing next-generation technologies for Twitter's ever-growing real-time needs. Dubbed Apache Heron, he was also an early member of Google's AdSense product. He holds a B Tech in Computer Sciences from IIT Guwahati and MS in Computer Science from UW-Madison. Sanjeev, thank you so much. I'm going to go ahead and mute myself and let you share the magic with us.
Thanks a lot. Thanks for the nice introduction. Hello, everyone. I'm Sanjeev Kulkarni. I'm a senior principal engineer at Splunk, working on the data stream processor. Data stream processor, if you've heard Karthik Ramasamy talk in the keynote, is Splunk's own take on making it easy for enterprises, whether you're big or small, to analyze and get value out of your real-time streams in real time. So today's agenda, I'm going to go deep into the architecture, the internal architecture, the implementation details of Pulsar Functions. We'll start with a brief introduction to Pulsar Functions. Pulsar Functions, I have spoken at various different conferences. Others like Jerry, Matteo, CJ have spoken about it in various different places. So a lot of people have given like what is Pulsar Functions, how we are going to use it, how one can use it, and so on and so forth. So I'm just going to briefly go over the concepts and genesis of the functions. But the bulk of the conversation is going to be on deep dives. We're going to be, in particular, working in the submission workflow. What happens when someone actually says, "Hey, create a function or update a function." Then we'll talk strictly about how functions are scheduled, who decides where some function should be running, and so on and so forth. How does that mechanics? How does that dance work? Then we'll talk about execution workflow. What happens how exactly are functions started? How exactly are functions executed? Like who manages? What are the internal structures that manage the life cycle of functions? And we'll do a little bit of segue into Java instance in particular, right? Like Java instance is Pulsar Functions for Java. And it's interesting because it was the first one to be developed, and it usually is ahead of all other languages. And B, the framework of Java instance is also used by a bunch of different ancillary Pulsar projects, specifically Pulsar IO. So I'm going to go into a little more detail about the Java instance and how that nicely connects with Pulsar IO. And then, we're going to be talking briefly about, what we are doing with respect to, some of the pitfalls, some of the feature work that's happening at Splunk or at OSS about Pulsar Functions, the various enhancements that we are making. So without further ado, let's begin. Functions, right? So what's the core concept behind functions? Well, the whole idea was, serverless. We saw serverless turning into this big, huge, giant monster, right? And it was a big hit amongst all the cloud providers, especially AWS Lambda, right? And one of the primary reasons why it was so popular was its simplicity, right? Like people understood, like everyone, whether you're you may have 10 years expertise in programming, or whether you're a newbie, you understand what a function means. You were able to get started with functions very quick. Right. So the core concept of Pulsar Functions was that we wanted to bring those kind of serverless concepts into the streaming world. And abstractly, from an abstracting, we also noticed that functions were a very easy fit, very natural fit to the streaming world, right? Like in the right-hand side, if you see, streaming, you have a bunch of incoming messages, and these incoming messages never really stop, right? So a functions naturally is, every time a message comes in, you want to see and you want to act on that message, and that's actually a function, right? And then this function may produce something. right? It could produce something optionally, or it could update its database, or it could flag occasionally, hey, something is not right, and so on and so forth. But whatever the logic of the function is, occasionally it produces something. And if you sort of look about it, that's a natural output topic. Messages go to an output topic, right? So that's basically what Pulsar functions are all about. They are a simple, thin processing logic that glues an input topic to an output topic, right? And then of course, the input topics could be not one but many, and output topics may or may not exist, in the sense that the function may or may not output anything, or may output occasionally. Again, simplicity was the key to everything that we designed for Pulsar. So one of the main things that we wanted people to do when they were using Pulsar functions was that they need not actually learn any new API, right? So anyone who knows Java programming language, right, using whatever is existing inside the Java SDK, they should actually be able to write a function and get started. Like, for instance, in the right-hand side, you see an exclamation function. We don't have any additional SDK. The Java util function is available to you in the Java SDK. And you basically say, I'm going to write a function that expects a string and outputs a string. So essentially what you've declared is, I'm going to write a function that's going to treat the incoming messages from the incoming topics as strings. I'm going to do some logic here, which is basically apply an exclamation symbol. The classic, hello world equivalent in the streaming world. And I'm going to output that. And that goes into an output topic, right? So the emphasis was purely on simplicity. And this is great for 90% of the use cases, right? If one is wondering, like, majority of the use cases, even at large enterprises like Twitter and so on and so forth, they are concerned about filtering, they're concerned about routing, how do we go, how do we take a topic, how do you take a message and route it to a different topic and so on and so forth? Or how do I enhance, like, there are some missing fields, how do I enhance and so on and so forth? It's a perfect fit for all of these kind of things. And at the outset, the aim was not to replace Spark, Flink, or any other heavyweight streaming engines. Heavyweight streaming engines have a place. The aim was, for your 90% use cases, you can get away with a simple API and a simple API in simple execution framework. So that was a core Genesis idea. And built in, we wanted anyone to be able to write these functions, submit them to the existing Pulsar cluster, and use it right away. So they need not actually be bothered about, hey, how do I actually run these, right? I mean, if they want to, they can, but out of the box, Pulsar itself should provide a lifecycle management of all of these functions. And as a result of which, today, if you download the standalone version, you can submit your own functions, and the Pulsar actually takes care of making sure that the functions are started, stopped, and making sure that they are migrated from a dead machine to a non-dead machine, and so on and so forth. And all of this, you can do this using a very simple CRUD-based REST API, which means that you can actually submit it from any workflow and have them running. So that's it about a brief introduction. So let's actually go over, okay, what actually happens? Like, how does the whole internal workflow work? Like, we'll go on the submission framework. Like, what do you do when you're actually submitting a function? The key structure when you are actually submitting a function is what's called as a function config, right? And this is a function config which is where you say, hey, what is my function is all about, right? The key thing that you're saying is that, hey, look, my function stays in a particular tenant and namespace. Just like a topic, a function stays in a particular tenant and namespace. So it has a tenant, namespace, and a name, right? And then you're saying, hey, look, my function has this particular class name, right? And it takes a bunch of inputs, it has an output, and you can supply a bunch of user config. We support secrets management as well. You can say, hey, you know what? Don't run one, but run 10 instances of this function. And each of these should take this much amount of resources, this much amount of CPU, this much amount of RAM, and so on and so forth, right? So essentially, you pass in this JSON representation of this particular function config class. There are a lot more knobs than what I'm showing out here, but you sort of get the basic idea of what you're actually doing when you're submitting a function here. And along with this, you have to submit a jar file, like a fat jar or a Python file or a Go file or something like that. So what happens? So you submit it to the function worker. Now, the first thing that we need to do is, we do some, basic things like, hey, is the person who's submitting the function, hey, who is saying to be, is he the right person? And does he have the right privilege to submit the functions in this particular namespace and tenant? And then we do a bunch of validation. What sort of validation is this? Hey, is the function config that you've passed, is it all kosher? Are you missing some fields, or are you passing some fields that should not be present, and so on and so forth, and so on and so forth. And for Java, because this whole framework is written in Java, for Java functions, we actually do far more sophisticated checking. We actually load the classes at submission time and make sure that the classes that you said actually exist in a jar file. All we do this so that you, as a user, get the error message as quickly as possible, right? You don't want to submit something, wait for it to be scheduled, then look at the error messages in the output logs to go and then correct whatever mistakes you're doing. You want the feedback as early as possible, and that's the reason why we do this validation at submission time, right? We want to make sure that the user class that you're saying actually overloads a function base class, and so on and so forth. So all the usual suspects of doing validation is what happens in the submission text. And then you can actually you've actually probably sent your code along with the function creation time. So what do we do with this code? We actually copy the code to the bookkeeper, right? So once you've sort of submitted your function, from this point onwards, we know everything about this function, right? We know what it is all about in the function config representation, and we know the bits of where the logic, the actual jar file or a Python file exists, and that's in bookkeeper. We know the handle to that thing. All of this is represented internally as function metadata. Right, so it's a protobuffer structure. We chose the protobuffer structure because we can evolve it, right? As and when we add new fields or new capabilities and so on and so forth. Protocol buffers have this very natural ability to be backwards compatible with previous versions and so on and so forth. They provide serialization and so on and so forth. So all the nice things about protobufs, we sort of use here. So you sort of look about it. We have the actual function details. So the function config that you passed in the previous, the previous things get translated into a function details protobuf message. Then we have the package location. Where did we actually store this? Your jar files. Where did we store it to the bookkeeper? We have a handle to that. We have this version, which I'll come to it in a little bit later. And then, we have a bunch of information about authorization and stuff like that. I'm going to omit that because it's not really relevant to this. But these are the steps that we basically do. So at the end of the day, what we have is this function metadata structure. Now, all of this inside the function worker is managed by what's called as the function metadata manager. So essentially, from a worker perspective, the function metadata manager maintains the system of record. It knows for all the functions that are there in the system, it maps from what we call as FQFN to the function metadata. What is this FQFN? It's the short form for fully qualified function name, right? A fully qualified function name is like a fully qualified topic name, right? It consists of the tenant information, the namespace information, and the function name information, right? So that's what we call, that's what we mean by when we say fully qualified function name, right? So essentially, the system of record maintains the mapping between the FQFN to the function metadata. What is function metadata? And by the way, this is all backed by a Pulsar topic. So all of this is written to a function metadata topic, right? And basically everyone is tailing this function metadata topic. And I want to actually go through that workflow of how exactly this happens. So let's just say this was your original state, right? So you have a function metadata manager, which has a tailer, which is actually tailing the metadata topic. And you have your system of record, which says foo, which is basically, let's just say a function. And, it has its detail. Its function details is blah, blah, blah. It's version number 2, and so on and so forth. So this is what the system state was just before, someone was actually, say, updating a particular function or creating a particular function or deleting it for that matter. Right. So when someone actually submits this update thing, we first make a copy of the current state for that particular function. So we say, okay, I'm making a change for this function foo. Let me see what my current state is. And here is my current state as seen in the system of record. Okay, I want to make some update, right? Like for instance, let's just say you want to, stop some of the instances of the function, right? Or you want to change the user config of this particular function, right? So you merge in whatever updates you want to make. And that is basically in the function details. So the function details now contains the merged information. So then what we do is that we actually change the version number. We increment the version number from 2 to 3, right? Note that this is happening only in the copy that we have made. The system of record, which is actually what is the real thing, still is at version number 2. And then we write this to the metadata topic. So once we write it to the metadata topic tailer is constantly scanning for new messages on this topic. So it actually reads this version that we have written. And it actually verifies that, hey, look, this looks good. The metadata, the function details look good, and that there are no conflicts. And only when there is no conflicts and so on and so forth, it then actually changes the system of record. Right now, you can sort of see here that the system of record now has version 3 with the updated function details. So essentially, we have said that we have admitted this request. This request is all good. So we've updated whatever our state of record to the version 3 of the function. Wait a second. Why do we go through all of this dance? What do you mean by conflict? Why do we actually do this complete dance of writing to a topic and then reading back same message again? One of the key things that we do is that any worker actually can handle the update messages. So when you're actually submitting update function, that request can actually go to any one of the different routers, any one of the different workers. So let's imagine this hypothetical scenario when there are multiple workers. Here there are 2 workers, worker 1 and worker 2. And they both have the same state machine. So at some point of time, they both had the same, the function of the details about function foo. Now, let's just say there were 2 concurrent requests, 2 different concurrent requests for the same function foo, right? Now, one is coming from worker 1 and one is coming from worker 2. Now, worker 1 makes a local copy of itself and writes it to metadata topic, and worker 2 does the same thing, right? Now, what we are saying is that whoever is able to write first wins. That is the key capability. That is the key serialization that Pulsar itself does for us, right? So this is how we are basically serializing. This is how we are basically letting one request wins over the other. So for instance, let's just say if worker 1 had a request that updated the function and worker 2 said delete the function, right? And they were both happening concurrently. If blue represents worker 1, right? Worker 1 wins because it moved the version from 2 to 3, right? Because after the version 3 has been read, when the tailer goes into the next message, the orange message written by worker 2, that version is already less than the updated version in the state table. So that particular request is rejected. So the user who's making the delete request on worker 2 will get a message back saying, hey, someone else has already made a change. So can you please try the request again? So that is kind of the behavior that this particular things is, and this is the reason why we go through this whole dancing of write first to the topic, make sure that the Pulsar topic serializes it for you, and read it into the state machine. So what are the advantages of doing it this way, right? I mean, the principal advantage is that you can now submit it to any worker, right? You don't have to designate a particular leader or a bunch of leaders. You can just submit it to any workers in your system, right? Remember, when an update or a create function happens, there's a lot of validation, especially for Java functions and so on and so forth, right? Now, this validation load, because it's happening across all the workers, scales very linearly because it's kind of distributed. The state machine is very deterministic, so it's easy to read a bunch of records and arrive at the same conclusion in all of the same state machines. And naturally, because we are actually writing all of this in the metadata topic, this is a very nice audit log. The metadata topic sounds as a very nice audit log. Of course, there are pitfalls here, right? One of the major pitfalls is that the metadata topic growth could be huge, right? Because we really are not garbage collecting it. So imagine submitting and deleting millions of functions. The metadata topic now has millions of messages, right? Every worker, when the worker starts up, needs to go from the start of the metadata topic to the end, so that it can get its state machine up to what the current state of the system is, right? And as time goes by, this startup time basically keeps on growing and growing and growing, right? The other issue that we have is that all the workers have information about all of the functions. That's good, it's simple, but would that actually scale to a billion functions? Probably not. Right? It might scale to millions of functions and so on. So, which is probably okay for most of the people, right? But that might be a scale topic and so on. There is a lot of work going on in the OSS community about addressing some of these pitfalls. I'm going to come back later about what we are doing, what are some of the approaches that we are working on to address some of the pitfalls that we sort of see. But moving on, now that the system has accepted a particular function, how does it get scheduled? So at Functions, we provide a pluggable scheduler. So the system itself comes with a default round robin based scheduler, right? So whenever a new function is admitted, right? Whenever a new function is created, updated, deleted, and so on and so forth, we invoke this function, right? Or whenever we see an ensemble change in the membership and so on. The scheduling only happens at the leader. Wait a second. We said that you can actually submit it to any of the workers. Where is this leader business coming from? So one of the workers is elected as a leader, right? And the leader election happens via a coordination topic, right? Pulsar already provides this primitive called failover subscription. Right? Using failover subscription, if you have a topic and if you have multiple different consumers, only one of the consumers gets to be the real active consumers. All of these consumers are on standby, so that if this consumer, if the main consumer fails, one of the others will get over this. That is a perfect workflow for doing a leader election. So we use an already existing mechanism inside Pulsar to elect one of them as a leader. So anyone who's basically working, who's basically is the consumer of this coordination topic is going to be the leader. Now, the leader, schedules, and after scheduling, it writes assignments. And all of these assignments go to another topic called as the assignment topic. So all of these topics that I'm talking about, the metadata topic, the coordination topic, the assignment topics, these are all basically system topics. They exist in a particular namespace inside Pulsar. So in this particular case, for the assignment topic, this is written by the leader, right? And it's actually very nicely compacted. Because the key is now the function, the fully qualified function name plus the instance ID. So if the function has 10 instances, each one of these will be an assignment, right? Instance 0 goes to worker 1, instance 2 goes to worker 2, and so on and so forth. Right? Again, we take the same approach as what we did for function metadata. All the workers know about all the assignments. It makes the state machine, again, the same state machine, very simple. The assignment topic, again, stores the assignments. The assignments are all protobufs. All of this system logic, whether it is function metadata or the assignments, they're all kept as proto messages. Again, for the reason that proto messages provides, backwards compatibility and serialization, right? So, and it's again, it's compacted, and the compaction key that we sort of use is the fully qualified function name plus the instance ID. So if you sort of see here, the assignment is, what is the instance we are talking about, which is the function metadata and the instance ID, and which worker is this assignment going to, which worker should actually execute it. Okay, so we admitted a function. We know that there is a leader, and the leader executed something. That the leader scheduled something. How does the execution happen? So the execution happens by the changes to the assignment table. So the component inside functions is called the function runtime manager. And the runtime manager is responsible for whenever there is a change in the assignment table, as depicted by assignment Taylor, it says, okay, what should I do? Should I kill this message? Should I create this message? And so on and so forth. And it itself uses something called as a spawner. So a spawner is something that abstracts out the execution environment. So remember, you can execute a Pulsar functions as a thread, as a process, or a pod, and so on and so forth, right? All of that is controlled by something called the runtime factory. And the spawner hides all of this information away from the runtime manager. So it's a spawner which actually uses the gRPC channel to the function, so it can actually talk to the function. Right? It can say, hey, give me all the messages that you have said. It can even send some termination commands to the function. Hey, clean up because I'm going to terminate you, and so on and so forth. So all of that is maintained by the spawner. Anyone who has played around with functions knows that there is something called as a local runner, right? The local runner is nothing but this same spawner, right? The local runner, bypasses the function metadata manager, bypasses the function runtime manager. It directly runs spawner, and the spawner basically does everything the same thing. So before, instead of these things, let me go over Java instance topics, because I think I have like about 3-4 minutes left. If you look closely into the Java instance, the Java instance actually is encapsulated as a source, function, the actual logic, and a sink ensemble, right? Source is essentially a construct that abstracts reading from input topic. Sink is an abstract concept that writing to an output topic, right? So if you look at a regular function, the source is nothing but a Pulsar source because it is actually reading from Pulsar. And the sink is a Pulsar sink because it's actually writing to a Pulsar sink, Pulsar topic. Now, why did we do this way? Because the idea was, if we now substitute, let's just say, instead of a Pulsar source, a non-Pulsar source, let's just say we're reading from a Kinesis, or we're reading from a Google PubSub, that becomes a connector. And here is where we sort of segue into Pulsar IO. This is the reason when we say Pulsar IO is actually using the same execution framework as Pulsar functions. So a Pulsar IO source, for instance, has the exact same thing as a Pulsar function, except that instead of using a Pulsar source, it's using a non-Pulsar source. And this non-Pulsar source is an abstraction that anyone can basically write, right? And the function here is an identity function. So whatever the non-Pulsar source generates, the identity function is just purely going to pull that in, and the sink, which is the Pulsar, will write it to a topic. So this is a Pulsar source. And naturally, a Pulsar IO sink is nothing but you're actually reading from a Pulsar topic, passing through the identity, and writing to a third-party system. So this is how naturally Pulsar IO kind of fits into the architecture of the Java instance. And that's the reason why Pulsar IO is built on top of Pulsar functions. Briefly, touching upon a few of the current and the future work that we are sort of working on. One of the things, one of the current issues that we have is that once you sort of set up Pulsar functions, a particular setup can only launch Pulsar functions as threads or processes, right? I, as a user, cannot say, hey, run this function as a thread versus run this function as a process, right? So that is, that is mostly some changes in the function runtime manager, but this is something that, people are taking over in the OSS. As I told, function metadata topic that grows out of bound, and for really long learning systems, that could be a problem, right? So topic, how do we do topic metadata compactions? There is quite a bit of work going on in the open source world. Function mesh, remember the whole idea of function is that it's a simple transformation from input topic to output topic, right? Now, I actually want to chain a bunch of these topics and functions together, right? I can do that right now, but is there a simple interface, a simple workflow API that allows me to do it more easily? So function mesh is this exciting work, that's being led by Neng, and it allows people to easily chain functions in a very natural manner. Batch sources. We've seen, there are these sources which are not really streaming. And a classic example of is an S3 source where files are magically appearing every so often. So you have to periodically or by some event go see the discovered, oh, I have 10 new files that I need to download and download them, right? How do we make it easy so that the framework itself has support to doing these kind of sources? So that is an exciting work that's going on in the open source world. So with that, I open the floor for Q&A.
Yes. So Sanjeev, you have a lot of questions. So if you can quickly, within the Zoom screen, click on the Q&A box. Do you see, if you want to stop sharing your screen as well, real quick, you can do that. You want to stop sharing screen. Here we go.
Stop share, okay.
Yeah, and now,
yep,
we can see just you now. Awesome. So if you click in the Q&A box at the bottom of the Zoom, you see you have a lot of questions. Okay, and they're growing by the second. So just answer them out loud, just go through them. Floor's yours.
Okay, so let me start with this thing. So in case I want to load configuration rules to functions, what is the best way of doing it? Let's assume running it in worker. Configuration rules to function, I'm not sure exactly what you mean. I'm assuming user configuration. So you can do user configurations in one of the following ways, right? You can actually pass it as a map to in the function config itself. Or the other thing that you can sort of do is that, write it to a particular place, let's say an S3 bucket and so on and so forth, and have a pointer in your function config. I hope I answered that question correctly. In case the function configuration, so if the function configuration changes, you need to basically update the function. So, invoke the update function. The update function is basically going to relaunch the function with the newly updated configurations. Can you compact the metadata topic? Yeah, so the compacting metadata topic is not as easy. You can. There is a work going on right now as you sort of speak. One of the reasons why we cannot do a simple compaction like we did for assignment topic is because certain messages are actually discarded, right? The way in which the default compaction kind of works is that the last writer wins for a particular key, right? But that's not the case in terms of the way in which we are using function metadata. It's actually the first one that wins. And it's not just first, right? It's basically the first concurrent wins. So if there are two updates being made, but not concurrent, then the second one wins. But if there are two updates being made, which are concurrent, then the first update wins. So this is the reason why compaction of function metadata topic is a little bit complicated. However, there are some proposals wherein we are thinking of sending, after the validation is done, sending the actual writing to only the leader. But this is something that I can follow it up. It involves a lot of details. I can follow it up with you directly. Will the leader be a bottleneck or a single point of failure? So the leader is typically just doing scheduling, and the way in which, so that's the leader is not involved in any kind of data path, leader is not involved in submissions and so on and so forth. And second part is that leader election itself is happening via standby leaders and so on and so forth. So if the particular leader goes down, the leader election happens pretty quickly, and the only thing that's affected in the meanwhile is just scheduling. So it should not serve as bottleneck for much things. Shouldn't the compaction be based on FQFN without instance IDs since you have a single assignment of worker? I'm assuming this is for assignment topic. No, because for a particular function, let's just say a function has 10 instances. Each of the instance of that function can go to different workers. As a result, each is a different assignment per se. And that's the reason why the key of the assignment topic is both the FQFN plus the instance ID. You mentioned function code shipped to Bookie. Why call that out explicitly? Oh, sorry, I missed that. Okay, why call that explicitly instead of mentioning that system topics are used? Also, in true sense of function shipping, function execution happens in Bookie or broker nodes, and how is isolation? Okay, so the code for executing function, the user code is copied to Bookie because we want to maintain that somewhere. And because Bookkeeper is fault tolerant, distributed storage, we use that. The second part of the question was that, oh, sorry, I forgot the second part of the question. I believe that was, execution of the functions. So the execution, so you can actually schedule the worker nodes either on brokers or on a separate set of machines. So the execution is very flexible, right? So you have your pub subsystem could be completely different from your nodes which are executing functions because they are on worker nodes, right? So the execution mechanism is very, very flexible. Is this worker another separate component in Pulsar cluster? Yes, it's a separate component. It can be run alongside broker, right? Just like a bookie can be run alongside a broker as well, right? Similarly, a function worker can be run alongside a broker. However, it can also be run as a separate component. So this way, you can truly, start with a single one. Like for instance, you run your Pulsar standalone, you're actually running bookie, zookeeper, broker, worker, all in one single JVM, right? That's possible. However, you can also scale each one of them differently. So you can have your own set of worker nodes and scale them according to the number of functions that you're executing, right? Just as now you can scale the number of brokers and number of bookies and so on and so forth. So we purposely isolated the various different layers so that they can be scaled differently. Can a function be an input output to another function? Yes, function chaining is specifically possible. Function mesh is actually going to make this chaining very, very easy. If you have a hybrid, microservices consume and produce messages and functions. Do you see the technique that microservices itself deploys the functions and jars? Absolutely, right? One of the whole reasons of functions was that you can think about microservice as a function, right? So suddenly you can use Pulsar functions as a way to deploy microservices. So exactly. So that's definitely a method that's actually being used inside Splunk as well. Does function have state? Yes, state is something that I did not go in because of the short time I had, but function uses like Bookie has something called as a state service, and function actually has the context has state serving mechanism. So you can actually save a counter, for instance, right? Like your famous word count example, each of the individual instances of the function can say, hey, increment a particular word and so on and so forth, right? And the state store leaving in bookkeeper, increments, or you can save arbitrary states in if not counters and so on and so forth. Can you tell more about coming local state? I'm running out of time. I would love to answer the local state is a little bit a bigger conversation. Please reach out directly to me in case if you have questions there. We are using Pulsar functions as a fan out router to ephemeral topics, but the problem functions prevent topics from being deleted. Does function maintain a live producer for every dynamic topic it sends data to? The function does actually maintain a live producer for every dynamic topic, but you're saying that the topics cannot be deleted because the functions have these things. Yes. So what I would suggest is that you can actually do an update. The other thing that I can sort of think about is that you have this interface inside the context called as new producer. We can probably provide another interface called close so that you can actually close it inside the function, and then you can delete the topic after the function has closed it. So reach out and submit a GitHub request. It's a probably an easy thing to do. How to manage traffic tracing, exceptions, retry timeouts, and function pipeline? Great question. So remember, I talked about this gRPC channel that the spawner maintains with the function. So the spawner is also maintaining all the exceptions that it saw or the instance saw, right? So when I say get status, from a particular function, the spawner knows the list of exceptions that the function has undertaken and displays the list of functions. So you can actually do a get status of a function using the REST API, and that should list you the list of all the exceptions. So you need not go to the function slot directly, but you can access the function exceptions using the REST API itself. I believe that is all, and I'm 1 minute over.
Sanjeev, you need some water. What you just did was marathon amazingness of answers. And I noticed the more you were answering, the more the questions were popping up. Now, you mentioned to folks, hey, they can reach out to you. What is the best way for them to, what's the email? What's the Twitter?
So at the beginning of this presentation, I shared you my email,
yes.
sanjeevk@splunk.com. That's one way of reaching me. The other way of reaching me is via Slack. So I am active on Apache Pulsar Slack. And just hit me at Sanjeev, Sanjeev RK, and you should be able to reach out to me directly. So those are I would say my two preferred ways of people wanting to reach out to me.
Fabulous. Well, Sanjeev, since other folks cannot clap for you since they're not on audio, I'm going to clap for you real quick because this was fantastic.